Hey everybody, this is Larry. This is May 26th, day 26 of the May Leetcode challenge. Hit the like button, hit the subscribe button. Let me know what you like about this. I've been doing this every day, so if you want to watch daily problem solve, hit the subscribe button. Anyway, contiguous array. Given a binary array, find the length of the maximum length of a contiguous subarray with equal numbers of zeros and ones. The length of the given binary array will not exceed 50,000, so n is 50,000. Okay. Hmm. So I So I think this is actually last month's problem, if I'm correct, because I remember I tried to do something with prefix sums or something like that, and maybe a two sliding window from prefix sums from the zeros and ones. Um, I'll post a link below on how I solved it last month or last time I solved it. Let me know what you think. That said, this gives me an opportunity to improve on what I did last month and prove that you learn from your mistakes a little bit. But from what I remember, um, the thing that fooled me was that it was using zeros and ones. Um, so that's why it led me to using prefix sums and then sliding windows of that. But from what I remember, and also after I converted to, because this is equivalent from just two alphabets, which is A and B, and from that, the maximum length of a contiguous subarray of equal numbers of zeros and ones, or A's and B's, are just, um, it is the same as the equivalent of dynamic programming problem, where you sum to zero, where one of the digits is -1 and one is +1. So doing that, I think we have enough to do the dynamic programming thing. And I'll kind of illustrate it as I code, so follow with me. Uh, but cool. So let's just say dp is equal to, let's just say collections dot default dictionary of an int. So that gives me a dictionary that always has zero. And then now so for index, because we need the index to get the longest contiguous array. So it's not just the count. So one of the how you do the dynamic programming is try to figure out what you're trying to solve, obviously. But for index x in nums, okay. So now, let's keep a running count of the current sums. So this is kind of like prefix sums, um, but prefix sums not on the zeros and ones, but on our modified array of -1 and +1s. Um, so yeah, so count. Oh, I was gonna say if x is equal to 0, then we just subtract 1. You could also do it the other way. It doesn't really matter. I guess this is always true. So let's increment by 1. And then now dp of count is equal to, actually, I guess we don't use default int in this case. Whoops, how did that? We'll just do a regular dictionary. And then if count is in dp, then we don't do anything. So if count is not in dp, we set it to the current index. And then now we can return the longest is equal to 0, say. And the longest is just equal to max of index minus dp of something, and longest. And then we return longest. So what we want to do is say, given an array of -1s, 1s, and so forth, we for each element, for example here, our current count is +1, right? Our current prefix sum is +1. That means we have to find. That means x plus some other y is equal to 0 is what we want. So we want to find, in this case, a -1, and then we want to find the earliest index where the prefix sum is -1, which in this case doesn't exist, I suppose. Actually, sorry. we want this to be true because because for prefix sum we want this positive 1 represents the sum of the prefix array here, right, from this span. And we want to try to find a prefix sum that is to 1, also to positive 1, so that this index minus whatever this index, so that this this prefix sum minus this prefix sum is equal to this segment, where this segment sum is 0, right? So now we have x minus y is equal to 0, where x in this case is the current running sum. So okay, so that means count is maybe a terrible name, but okay, so that means we just have to do. So what we're looking up is actually the same count. So then we just do count here. So you may ask, why am I doing this so slowly and explaining a little bit? Because for me, I actually get the sign wrong a lot with these with this type of dynamic programming. Sometimes I do plus, sometimes I do minus, sometimes I do plus here, sometimes I do negative of that. And when you actually work out the formula of what you're trying, and you visualize this, I have a pen of paper by my side as well, but I just want to visualize as well to the audience, is that once you're able to visualize what you're calculating, then you're able to do this prefix sum a lot easier and able to get the longest array a lot easier. And why we, well, let's actually run the test first. Should be okay though. Oh, whoops, I meant enumerate, of course. Enumerate let us maps the integer that's in here with an index number. Okay, wow, so this is not right. But, oh, first, well, the reason I'll get to it in a second, which is fine. But yeah, okay. So this looks mostly okay other than that. So the reason why this is wrong is because we don't have one for, so we create an entry for each, after each prefix sum, after we process every individual number, but we don't process one for the no element, which is no element, so it doesn't count at 0. So we just have to add, in this case, dp sub 0 is equal to 0. No, maybe negative 1 in this case. Though, yeah, negative 1 being even before, because we want this index to be the index finishing at a certain index, meaning it's inclusive of the num subindex. So negative 1 means that it doesn't include any of those. So that should be okay. Let's run submit, and let's go with it. Cool. Yeah, this time I believe I solved a lot faster. That's what practice gets you. But yeah, but for me, this type of prefix sum dynamic programming comes up a bit, and it's something that I'm actually a little bit weaker at because I'm really bad at, as I mentioned, I'm really bad at getting the signs right and getting the sometimes off by ones and stuff like this. So let's explain and go over this a little bit, and you can generalize this, right? Like let's say you're given a binary array and you're trying to find the longest subarray such that you have 5 ones more than 0. Well, in that case, instead of looking for zeros, then this is just 5. And in that case, you're taking this entire sum, which is, let's just relabel this to all sum to now, and all sum to 5 maybe, meaning this second bit, and it's equal to 5, right? And then now from here, it's easier to see that it's easier to see how what is the number that you're trying to find and what number you're trying to put in by turning, by manipulating this formula. And that's the model that I've been mentally working on because I've been really weak at this. And then the other thing that's special about this problem is that it comes up very often there are maybe a couple variations, but the variations that I am more familiar with is there's one variation with like it could be another case where count the number of subarrays where there are equal numbers of zeros and ones, and in this case, that's when you actually um, keep a running count, and then you keep track of how many times that it has happened in the past. And we could go over that as well, but that's a variation that I've seen. But in this case, why do we keep track of index? So another way to think about this, the way that I write this is a little bit maybe not easy to understand. I mean, what it's saying is that if the count is not DP, put in DP. But what it actually wants to say is, let's say DP, maybe another way of putting it is DP is equal to the earliest index where, or like the first time we've seen count in the array, maybe, right? Because if it's not, because we want to get the longest, we want to get the maximum, which is the longest, and the longest happens in a greedy kind of way. The earlier you've seen it, the earlier you want it, right? Because let's say there's a variation where you just append the current index, and then you want the longest from index minus here, then you just take the first element, or the smallest element, which is, well, it's going to be just the first index. So this is an optimization that you get play around with. But yeah, that's all I have for this problem. In terms of explanation, I think. Let me know what you think. Leave comments, leave questions. We'll answer it as much as I can. And also hit the like button, hit the subscribe button. But yeah, in terms of complexity, this is O of n time, because for each element in nums, you're only doing O of one type operations, assuming that hash table looks about O of one, which you could play around with talking about that. And space is O of n, because the worst case scenario for the number of elements that we're inputting in DP would just be n. For example, if it's all zeros or all ones, you're just going to have just DP will just contain 0, 1, 2, 3, 4, 5, 6, and so forth all the way to n, and that's O of n. Cool. I think that's all I have. For interviews, I haven't really seen these type of dynamic program problems on interviews, but I've also been told that it comes up, so definitely study a little bit. For competitive programming, this prefix sum DP comes up all the time. I think not all the time, but like enough times that you should be familiar with it. But yeah, that's all I have for this problem. Let me know what you think. Let me know if I did better than last time if you watched last time's video. And I will see y'all tomorrow. Bye bye.